Hello and welcome to the fourth academic lesson on the fundamentals of sound design. If you've made it this far but haven't watched the previous lessons, I recommend going back to the playlist and reviewing them, because without the concepts we covered earlier, you won't be able to fully understand or apply what we're about to learn. So grab your notes and let's begin. Lesson 4, waveforms. All waveforms, except the sine wave, can be broken down into partials. A complex waveform can actually be analyzed as the sum of multiple simple components. These components are called partials or harmonics. The sine wave is a special case. It contains no partials, only the fundamental frequency. In contrast, all other waveforms contain additional partials, which, together with the fundamental, define the harmonic spectrum, or in simpler terms, the timbre. Call it as you prefer. Sawtooth wave. The spectrum of the sawtooth waveform is made up of all the partials of the natural harmonic series, first, second, third, etc., each with an amplitude inversely proportional to its harmonic number. Square wave. The square waveform's spectrum consists only of the odd-numbered partials, first, third, fifth, etc., of the natural harmonic series, again with amplitudes inversely proportional to their order. A common parameter found in VCOs, oscillators, related to the square wave is pulse width PW, which determines the width of the pulse. In some synthesizers, this parameter may be called symmetry or shape. By modifying this parameter, we can make the waveform more or less asymmetric. An LFO, low-frequency oscillator, which we'll talk about later, is often used to modulate the pulse width automatically. Triangle wave. The spectrum of the triangle waveform also contains only odd-numbered partials, but their amplitude is inversely proportional to the square of their harmonic number. Sine wave. The sine wave is the simplest waveform. Its spectrum consists only of the fundamental, with no additional partials. This is why it has a pure sound, free of harmonics. That's it for today's lesson. I hope it was helpful, and I'll see you in the next one, where we'll explore a new module. We've already seen VCO in previous lessons. Next time, we'll dive into the VCF and analyze it in detail. Thanks, and see you soon.